All right, everybody, this is Mr. Warwick, and today I'm going to be guiding you through 3.2.6, the triangle proportionality theorem, or the side splitter theorem. This one doesn't have a whole lot to it. It works like this. The triangle proportionality theorem says that if a line is parallel to one side of a triangle and intersects the other two sides of the triangle, it divides the sides into segments of proportional lengths. So basically what we looked at yesterday with similar triangles, triangle ABE would be similar to triangle ACD, but you could also take it a step further and say top over bottom, and have that be a good proportion for you, and it would work. So if we're looking at something like this, where we have 28 and X on this side and 56 and 21 on this side, we can actually say 56 minus 21 is going to give us 35. So we have 28 to 35 here. So that's 4/5, right? So X is going to be 4/5 of 21. So 21 divided by 5 is going to be 4.2, and we multiply that by 4, we got 16.8. X would be 16.8. Okay. Again, you can just go small over big, small over big. You could say that 28 is to 35 as X plus 28 is to 56, and you could work it out that way. There's a bunch of ways that you can kind of set this up, but again, it's with the proportions just like we were doing yesterday. So it should be not too much of a challenge. On this one, it says in PQR segments ST and RQ are parallel. So if PS is 12.5 and SR is 5, if PT is 15, find TQ. So this would be 12.5 is to 15 as 5 is to X. If we go Desmos on this one, I'll just type that out as I'm saying it. 12.5 is to 15 as, back that out, as 5 is to X. Okay. And again, I'm looking at that. I'm just going from left to right. 12.5 is to 15 as 5 is to X. Okay. So I just typed that out so I can see it. What I would do if I cross multiplied is I would take 15 and multiply that by 5. And then I'm going to divide that whole thing by 12.5. I end up with 6. X is equal to 6. Okay, so this TQ here would be 6. All right, more sample problems is going to be doing the same thing over and over again. The converse of this is just if this line coming through here, ED, actually does split these into proportional parts, then this line is going to be parallel to this other line here, AC. So that'll be the two main things that we write in the notes. We check on this, and our work for today is in Delta Math. Now, let's view the assignments. The test and the review are both done, so those are going to be ready to go. So here we go with 10-2 triangle proportionality. We take a look at the skills. We're solving for a side with combined triangles. We take a look, and I made sure that this was all stuff like this. Okay. So this is going to be 36 is to 63 as 16 is to X. Yeah, 36 and 63 are both divisible by 9. So that's going to be 4 over 7. This 4 times 4 makes 16. So 4 times 9, this side over here is actually going to be 36. Okay. Oh, oops. That's what I get for trying to work too fast. Should have been 28. Okay. 7 times. Yeah, that makes more sense. Okay. So, again, we're kind of working our way through this. This one right here, same kind of thing. We have these different ones. Oh, why is it doing this? Okay, there we go. Something like that. OQ is 9, ON is 21, so I will actually type this one out so that I get it right. 9 is to 21 as, oh, lost it, delta math. And then PQ is 12, so it's going to be 12 is to X. So 12 is to X. I could reduce these, but I'm not going to worry about that. I'm going to say 21 times 12, put that in parentheses, divided by 9. I'm going to get 28 for X. So my X value here is 28. Okay, just need to make sure I'm dealing with the proportionate sides, setting it up correctly. This one, same thing. FG is parallel to CD. Okay, if FG is 1 more than EG and ED is equal to 6 and CD is equal to 8, find the length of EG. So this one here is going to be a little tricky. So I've got FG is 1 more than EG, right? So that means I've got to put small over big. So FG, they don't tell me what it is. They just tell me it's 1 more than EG. So in Desmos, I'm actually going to write that as X plus 1. And I'm going to put that over my big number here for DC, which is 8. So X plus 1 over 8 is equal to, and on the other one, I know my EG is X and ED is 6, so that's X over 6. So that's X over 6. Okay, so this is 8 times X, that's 8X. This is 6 times X plus 1, and that's equal to 6X plus 6. So when I go to solve that, I subtract the 6X from both sides. I end up with 2X is equal to 6, meaning that X is going to be equal to 3. Okay, now that I know I've got my X equals 3, I come back in here, I see what they're looking for, find the length of EG. EG was the one that was X, so X is going to be equal to 3. Okay, just make sure, like, again, it's going to kind of show you what's going on, set up the proportion, have the triangles there, cross multiply, same stuff that we did yesterday. Okay, and then the last section, the word problems with similar triangles. I'm not going to go over everything from this, but again, it's little over big, little over big. Okay, I'm just going to set this up as a proportion. I'm going to cross multiply. I'm going to solve. Just remember, when it says nearest hundredth here, hundredth is 2 decimal places. So we want to round to 2 decimal places there. Hopefully that gets you through. And if you have any other questions, you can save those for when I come back. Remember, tomorrow we are working on the review, and then Monday we will have the test. So make sure you're getting everything along the way. It's a good practice that way. Good luck.